Alright, so this video is going to go over function notation and function translations. So first off, a function is something like 2x plus 5. This happens to be a linear function because we know the graph would be a straight line. Okay, and the root word is line or linear. Okay, so that's one type of function. We start talking about a more advanced notation called f of x. Call this function notation, or I just call it fancy notation. Again, if you don't like it, remind yourself it's just the same as y equals. The reason, again, why we would do this, because if you had multiple people for your word problem or something, F might be the Frank equation, G might be the Gary's equation, H might be for Harold, M for Maud, N for Nancy. You can have tons of different equations in your setup, and you would just use different letters to represent them. So that's all this is. It's like a name of the function. Rather than calling everything F, we're going to use this. It also allows us to do more stuff with Desmos. Okay, so that's the notation we're going to be using. Okay, don't let it bother you too much. What we're going to focus on today is the graph of y equals x squared. Okay, and again, we're going to call it f of x equals x squared. So first things first, if we're going to make a table of values, you can choose the numbers in your table of values. So a lot of times people want to choose numbers like 0, 1, 2, 3. And we could do that. 0 squared would be 0 squared would be 0. 1 squared would be 1 times 1 would be 1. 2 squared would be 4. And 3 squared would be 9. Now that's great, but it only gives us part of the picture. It goes through 0, 0, 1, 1. 2 goes all the way up to 4. There's 4, 2 and 4. And 3 would go all the way up to 9. All the way up here. So we don't have a straight line. We have a curve. There's no way this thing is going to be straight. It goes from 0 up to here, but then it jumps. So it does curve a little bit. The other thing is, though, that's only half of our graph. And it turns out if you put in a -1, -1 squared would still be a +1. So on the other side, it would do the same exact thing. It would be a mirror image. Now, you probably graphed those before. Those are parabolas. This is what we call our parent function. This is our parent function. Okay, so what if this thing, what if instead we had, if we want to shift it over by 3, we put an x minus 3. How this reads is, replace x with x minus 3, and then it would be like x minus 3 squared. What's that do to the table of values? Okay, we're still going to make a table of values. What happened, though, is, take a look, and how we're going to interpret this is, everything got shifted by 3. Okay, but we're subtracting 3. So the way I'm going to interpret this is, 0 used to be 0. The new 0 will happen at 3. When I plug in 3, we'll get a 0 here. So it shifts all of our points over by 3. When we plug in 4, 4 minus 3 would be 1. Cubed is still 1. When we plug in 5, 5 minus 3 would be 2. I'm sorry. How did that should have been the second power this whole time. I'm sorry about that. That was this function, but I wrote the 3 twice. Sorry. So going back here. When you plug in 3, 3 minus 3 will be 0. Squared is 0. Plug in 4. 4 minus 3 is 1. Squared is 1. 5 minus 3 will be 2. Squared is 4. And when we plug in 6, 6 minus 3 will be 3. Squared is 9. So what you should see here is all the same numbers we had from before. It's just everything's been shifted. Everything's been shifted. By how much? Well, the old 0 was 0. The new 0 is 3. So this now actually happens over here at 3 is our new 0. 4 would be 1. 5 would be up here at 4, and so on. So it does all the same stuff. It graphs all the same points, but the whole thing got shifted to the right 3 units. That's going to be our shortcut for these. We're going to try and look at, okay, how does this thing change it? And it's going to shift the whole thing to the right. Okay, so it's the same exact graph. It's in the same family. It's just the same. It's been shifted. So we would say this is, if this was f of x, this would be the same f, but shifted by 3. That's how we want to read this notation. Okay. Take some practice. We're going to do a lot of it with Desmos, so you can practice that way, and we'll sort of see how things shift. Okay, let's try one more. Okay. So the function now is f of x equals x squared. That's our parent function again. Put a little box around this. That's the parent function. That's the parent function. If we write it like this now, if we say, hey, take that whole thing, but now let's subtract 5 from the whole thing. Notice this, read this as original function. F of x is the original function minus 5. So our new function would be x squared minus 5. That's going to be our new function with our new table. Okay. Now this minus 5 is happening afterwards, so we're still going to square the x. We can still try the same numbers we did before because nothing's happening to the x. When we plug in 0, we'd still get 0 here, but now the answer is minus 5. We shifted it down by 5. Okay. We plug in 1. 1 squared would be 1. Minus 5 would be negative 4. 2 squared would be 4. Minus 5 is negative 1. And it's not obvious what's going on here yet. 3 squared would be 9. Minus 5 is 4. It's not obvious. What happened, though, is if you take a look at these values, all of them are the same, but subtracting 5. 0 minus 5 would give you negative 5. 1 minus 5, 4 minus 5, 9 minus 5. So it's the same function, just shifted everything. Okay. That's kind of confusing, right? What we want to sort of see is, what does it do to the graph? Now, we knew the first one. We already graphed this one, 0, 0, 1, 1, 2, 2. Parabolas, you're going to see so many of them. The standard one, f of x, is going to look like that. The minus 5 shifted the start location down to 0, negative 5. So now it's down here, but shape-wise, it still does everything the same. So it's the same shape, but down 5. All the points, this point got down, everything got shifted down by 5. Everything got shifted down 5. So the table of values can be kind of confusing until you get used to it, but the idea is you're shifting all the points by 5 steps. Everything is getting shifted by 5. Okay. And what we're trying to do is go away from using the table of values. I'll show you what I mean with this last one here. Let's say y equals x minus 3 squared minus 5. Let's put both those ideas together. Okay, so the parent function is still x squared. It's still a parabola. I'll say it's in the parabola family. Inside things do a left or right shift. Outside numbers happen afterwards, and they're always up or down shift. Okay, so once you know that, this means the original function original x squared would look like that. This one's going to go, because of the minus 3, it actually shifted over to positive 3. I know that's weird. Let's talk about that. Even though it's x minus 3, positive 3 is what now is your new 0. Okay, positive 3 is your new 0. That's the way I remember it. Positive 3 would make this equation 0. Even though it's x minus 3, when you plug in 3 for x, 3 minus 3 would be 0. And that would leave you with 0 minus 5. So that's why it goes down here to negative 5. And that's your key point, and the shape is still the same. All right, that's the idea with these ones. Now, if you try these on Desmos, that should help. And I'm going to put together a video to help you with the Desmos ones as well. Okay, so pay attention to those things. If you got something x squared, you know it's a parabola. Anything you do inside, that's going to shift it left or right. Any number you put on the outside, that's going to be up or down. All right, practice, and we'll come back to it some more next time.